So in this video, we're going to talk about three important logarithm properties. Just to refresh on logarithms, logarithms are just another way, really, of writing exponential equations. So if you have log with this base, all you have to do is start with a base, and so the base to this power equals x. So the base to a power equals x, and that's just a way you can rewrite a logarithm as an exponent or an exponent as a logarithm. Remember, there are two special types of logs. If the base isn't written, it's understood to be a 10, and if it's ln, which stands for natural log, it's log base e, where e is Euler's number 2.718 approximately. All right, so what happens if I'm trying to solve this equation? The problem is there's two different logs. And so if I'm trying to do the whole like swirl thing and rewrite it as like 6 to the power of equals x, I can't really do it because there's two of them. So I need a way to condense them, to simplify them into just one log. So to do that, we need these logarithm properties. So there are three that are very important. One is kind of what we were just looking at, two logs being added together. So if you have a logarithm that's multiplication, you can split it into two separate logs with addition. If you have a logarithm that's division, you could split it up into two separate logs, but with subtraction. It's similar to the exponent rules. You know, when you like divide exponents, you actually subtract the two exponents, and when you multiply with exponents, you add the two exponents together. So it's similar to that. You can also go the other way. So if I have two separate logs, as long as they have the same base, then you can just kind of smash m and n together with multiplication. Or if it's subtraction, put them together with division. The base will stay the same. The base doesn't change this whole time. One final property is, if you ever are taking the log of something to a power, you can bring that power down to the front, and it is no longer an exponent, it's just multiplication. I like to think of this as like rescuing the cat from the tree. Bring it down to the ground. So, for example, on all of these, it just says to expand. That means I just want it to be, it's like the opposite of simplifying. I want it to be all written out like as long as possible, kind of expand it out. So, since it's multiplication, 2 times x, I'll expand it with addition. This is going to be log base 3 of 2 and log base 3 of x, but I'll add them. Again, the base 3 stays the same the whole time. If it's division, you do pretty much the same thing, but it's just subtraction. So I've got log base 4 of 16 minus log base 4 of x. By the way, I don't really need parentheses here because it's only one thing in the logarithm. If it's ever like multiple things, you might want to have parentheses to keep it more clear. This one is natural log, so it's going to stay just the natural log. And this one is not multiplication or division, but it does have an exponent. And so this is the cat in the tree. I'm going to bring that exponent down to the ground, and it just becomes 3 natural log of x. All right, you'll see why that's useful here in a minute, but it is actually really handy when we're trying to solve things. This last one has a lot going on. It has multiplication and exponents and division, so we're going to use all of these properties to expand it out as much as we can, and all of it will stay log base 2. First up is the division, because all of this is together in the numerator. So I'm going to start with the division. So I'll split up the 8x to the 4th and the 5. So I just split up these two here. And since it was division, this should be subtraction. Notice that this one can keep going because 8 times x to the 4th, that multiplication can be split up. So I'll split up the 8 and I'll split up the x to the 4th. So that's now a plus. So this split into those two. And then I still have minus log base 2 of 5. The only other thing I can do now is that's done, this is done, it's all expanded out, but I could go ahead and bring the 4 down to be in front there. So this could become 4 times log base 2 of just x. And now it's all expanded out as much as possible. All right. Usually we aren't trying to expand, usually we're trying to condense them into one log. So that's what we're going to do here. Simplify or condense each of these expressions into a single log, ideally. Remember, they have to have the same base to do this. So log base 2, we're good. It's going to all become 1, log base 2. And then I've got 3x already condensed, plus y. So I'll combine them with multiplication because it was a plus sign. So multiply them. Since this one is subtraction, I'm going to divide. So it'll all become 1 log base 3 of 4 over 20, which I can actually simplify. That would be a fifth, 4.2. On this one, if I want to deal with this 2 and kind of combine it to this stuff, I can put the cat back up in the tree. Bump the 2 back up in the tower here, and you end up with log base 3 of x squared. This one's going to combine a few of these things. I noticed it's subtraction, so I'm going to divide these two. Before you do that, you're going to want to go ahead and move these numbers up as exponents though. So put these up as exponents first, and then work on combining the two. So basically, like, deal with this first and this first. So I'm going to put the 5 up as an exponent, so that becomes log x to the 5th. And the minus needs to stay, but the 3 can be bumped up as an exponent. So that's going to turn into log x to the 3rd. Again, the minus stays, the 3 becomes an exponent. And now I can combine these all into 1 log base 5 of x to the 5th. Since it's subtraction, we're dividing, and x to the 3rd is on the bottom. Notice I can actually simplify this. 5 minus 3 would give me x squared. So log base 5 of x squared is my final answer. All right, this can help us when we're trying to solve equations. So kind of like we started off the video with, we can now solve stuff like that. I could combine this all into 1 log base 9 of x times 3, or 3x, and that equals 1. Now that it's all condensed into 1 log, I can do my little swirl and rewrite this as an exponent. So 9 to the 1st power equals 3x. And so to solve for x, just divide by 3. There we go. On this one, notice I have 2 logs, but they're both base 10, since nothing's written here. So I can combine them all into 1 log base 10. Be careful here. Since it's a plus, I know I'm going to need to multiply these 2 things together. But when I do 4 times x minus 2, I'll need to distribute that. So 4 times x minus 2, I'm going to need to distribute, and that equals 2. So let's do that. That's going to be 4x minus 8. Right. Now Now that it's all condensed to one log, I can rewrite it as an exponent and solve for x. Remember, there's a 10 here that's not written. So 10 squared equals this. And then just solve for x. So 100 equals 4x minus a, add 8 to both sides. And then divide by 4. What is that, 25, 27? All right. So that's how we can use condensing to solve log equations. Here's kind of the steps, if you like to have steps written out. Get one log equation by itself, so maybe condense some things. And then rewrite it in exponent form, do your little swirl. And then from there, just if you have to do any other work, solve for x, like you normally would. And that's it.